Hello everyone. Let me introduce myself before we are going through a couple of questions for the frequent asked questions here. So my name is Heri Laksana. So I'm actually the head of school for School of Physics in Faculty of Science and Technology, Airlangga University. So there might be couples of questions, couple of a bit unclear about how to apply for the School of Physics in Alumni University, as well as what the benefits and kind of things that it's quite helpful for students, for anybody in year 11 of high school. So these are couples of questions that it might be very beneficial and informative for all of you. Okay, so the first question that it might be a question to advise some students or audience is let me tell us about the story of the School of Physics establishment. So the School of Physics in Airlangga University is actually the same as normally the School of Physics in other university. It might be slightly different in some 1, 2, or 3 years, but usually the School of Physics in other universities in Indonesia, it started um, very early in 1950s. Some of them are 1960s, but by regulations, we are started in around 1980s, early of 1980s, because start from the regulations by the President's Republic of Indonesia in 1982. In 1982, so we were renamed into the Faculty of Mathematics and Natural Sciences since 1982. So as we can see that by then we established in 1982, and it was founded from the Basic Natural Sciences or BNS in the medical school formed by Dutch government before UNER was regarded as the national university in 1954 belongs to Indonesia. So yes, other School of Physics is usually started from FIPIA, which stands for the Faculty of Ilmu Pengetahuan Alam. So the School of Physics in Airlangga University has been started as the BNS or Basic Natural Science from medical school, formed by the Dutch government early or before 1954. So that's our history. All right. So by the times that we are going to progressive for the dynamics of the school, and we adopt couples of the standards, and we implement it into our school, and we level up all of the standards. So then we end up with the international accreditations in 2018. So the second question might be about the accreditation itself. So the School of Physics in Airlangga University here is actually already accredited by international accredited board. We call it as ASIN seal from Germany. So we've been accredited internationally since 2018. And to be honest, it's going to be due by 2023, which is next year. So we need to renew it next year. And what is the ASEAN's accreditation about actually? So by the accreditation, by the international accreditation, we actually get the benefits that the teaching process has been measured in international standard, which is quite demanding for some reason, but somehow it's going to be very beneficial for students while they graduated from this school. Um, we are not going to be evaluated and restandard by all the university or bodies or companies or work market outside Indonesia in the overseas, but we just already standard with the international standard as in Germany. So it's much easier for the graduates while the schools are still accredited by ASIN, right? So that's about ASIN, International Accreditation Board in Germany. So then, how significant is the ASIN International Accreditation here for our School of Physics in Airlangga University? So it must be a great momentum for school to level up to more prestigious level, since we start to run our teaching and research program in the international standard. So all of the requirements, all of the KPI, all of the assessments need to meet the international standards. And one of the very hard and needs some effort among the teachers, the lecturers and students, is because the lectures need to be taught in English, which is in the international languages, and we already moved up from some percentage of the subject, or we started bit by bit, but it's already improving from 30% to around 60% that we already been taught in English. And also we got some laboratories equipments for some experiments set up, which furthermore the ratio between the number of the equipment and the students in the laboratories while they are doing the experiments is lower than it should be. Okay, so this kind of the improvement, because it's very close to the investment and it's hard because it's very costly, but we are doing bit by bit. By the time we will meet the requirements, that the number of the ratio between the number of the equipment and the students in the laboratory is going to be lower. So it's quite important because the capacity and the capability of the students, the competence needs to be improved, and this is the way how we could do for the motoric skill or hands-on in the laboratory while they are doing something regarding to the skills. Okay, that's about how significant ASIN for the School of Physics. For the students, it must be very beneficial, as I mentioned before, that they are going to be graduated from the school that is already accredited internationally. The next one that it might be a bit unclear or raising some questions is because the government have already implemented the flexibility in the teaching and learning process, or we call it the MBKM, yeah, Merdeka Belajar Kampus Merdeka. So what is kind of the flexibility in the learning process while we are doing the MBKM? So flexibility learning is great chance for our school, and it's actually not for school of physics only, but it's for all subjects, for all study program, for all schools to expand and in terms of the manner and way how to meet the learning outcome they have assigned in the curriculum. So it's kind of that the border and the limitation between the schools are quite low. So you can't go over different subject, okay? Different school, different study programs, even different university. So this kind of the challenging thing, which is very beneficial for all of the students in Indonesia. You are taking some lesson here and there, so everything is going to be fine. Okay. Of course, it's the chance for School of Physics as the fundamental science as well to be getting closer to the application in industry, and it will empowering the students' capacity in their ability to implement their knowledge and understanding in physical concepts. So usually we still be hard to get to get in the implement to get the application or implement the theoretical of physics into the industry, but using this flexibility learning process or FBKM, we are going to get this process quite running through. It also enriches the engagement of school staff and students with the industrial for some reason. Yeah. We try to engage all of the staff, all of the lecturers into the business process in the company or the factory or the industrial bodies. So we are going to get more engaged with the stakeholders, with the market. Okay, so that's about the MBKM, the flexible. We call this flexible learning programs from the government. So we support that things, and I hope all of the students will get more benefits in this regard. So the next one is kind of about the interest or the research groups or the theme or the research topics in School of Physics in Airlangga University. So how many interests are the School of Physics has? Yeah. We do have 5 interests in physics, and it's ranging from the instrumentation and computation of physics, and followed by the photonics, material physics, biophysics, and theoretical physics. So it might be quite normal for School of Physics in Indonesia that they are varying from very different subject or very different interest. There might be without any biophysics, but for some reason they have the geophysics, or some of those don't have the theoretical physics, but they have the computational physics. Things like that, it's quite normal, so they complete each other. And again, with the MPKM or the flexible learning programs, we can also do comprehensively. Okay, so you can do some here and some of others, and the purpose of doing this is how we complete all of the competence, which is good for students. Okay, now I want to talk about the instrumentation and computational physics in our school, in School of Physics, Airlangga University, that the student will be pretty much so familiar with the control system, some modeling, and implements them in the industrial applications, such as they control some industrial instruments, as well as they will create some innovations to develop systems, how to monitor the industrial business and processes, and also improving their performance. So that's pretty much close to the instrumentation in industry, or it could also be in hospital and or the medical applications. The second one is about in the research interest in photonics. So in this area, the students might learn the power of light and its properties to be employed in some thorough measurements and sensing to investigate the physical phenomena in the micro scales, as well as to use them in even the communication system and technology. So that's pretty much the use of the light and its properties to be employed in some telecommunication technology and some sensors. Okay. The third one is going to be in material physics. So in material physics is pretty much close to the material science. So you are going to talk and discuss and learn how to distinguish between materials and assigning their properties to determine the use of the materials, and also carrying out innovations to improve their function into something more beneficial in various applications, from industry, for example, to medical applications. So that's pretty much about the material science, material physics. And the fourth one is going to be in the biophysics. We have the biophysics here, and in biophysics team or research group, we are going to have the chance to explore the use of some techniques or methods in some medical treatment on the basis of electric or sometimes magnetic or even electromagnetic, or reveal how they work to improve the cell performance. Okay, it's pretty much the applications of the life being. Okay. The last one is going to be the theoretical physics. This is, to be honest, is usually the tough one for the students. But yeah, luckily we have a couple of students who are quite interested in these theoretical physics research groups. The rate is about maybe 5 or 6 students per year, and we are employed per semester, or 12 to 15 per year, and the student will employ some numerical calculation using various techniques such as density functional theory, and to reveal the phenomena in the atomic and molecular level. So this kind of we are talking in very microscopic approximation, and we can also apply this calculation, this facilities, this methodology to different area. But in our School of Physics, we choose and employ them into for the atomic and molecular analysis of some materials. Alright, that's about the research interest in the School of Physics, Airlangga University. So okay, we move on to this the sixth questions about the benefits. What is the benefits for the students who will get into the School of Physics in Airlangga University? This is very crucial questions, because you are going to invest your time, your money, your focus for studying and learning at the university. And if you choose the School of Physics in Airlangga University, you might be you need to know what's the benefit and what you are going to be, right? So the first benefit, yeah, you will be as the physicist, because this is the school of physics, so you must be going to be a physicist, and you will have all the competence and capabilities as a physicist. You will know the principle, you know the very basic fundamental principle of physics, which is quite important for other technology. So it's going to be much easier for you all to understand the principle of the engineering. Alright, whatever the engineering you are interested in the mechanical engineering or electrical engineering or other automatizations or optimization or chemical engineering, all the process, they are on the basis of the physics concept. So this must be very easy for you to get engaged with the technology. All right, so let's we move on to the seventh questions. Yes, that's a very general issue, very common, and we already know about this. This is the questions, yeah. But students in high school normally do not like physics as it is very hard, tough, or sometimes it's creepy. What do you think, and how could we address this issue up? Okay, so yes, this is very understandable. That physics is hard stuff and very difficult. Very this basically it's not easy, completely not easy. But don't forget, do not forget that it's quite interesting stuff. Physics is still quite interesting stuff. We need to shift the paradigms that physics is hard stuff for students in Indonesia. Okay, so how to do that? From my point of view here, we will be very stressful to learn physics if we don't love physics. Okay, and from my point of view, we still have another way, the better way, how to understand physics. Yeah. So then, instead of doing the learnings or studying about physics, just play with physics. Do not learn about physics. First, you need to play with physics, so you will love it because it's interesting. Then, so forth, you can do starting to understand by learning about physics or studying about physics. But you need to love it first. How to make it? You need to play with physics. Alright? We call that getting engaged with physics means that you start to love it. You start to love about physics. Physics is fun, physics is interesting, physics is able to explain anything in a simple way, okay? And more importantly, physics is quite makes sense, okay? So start with while you love it, then you will get engaged with physics, yeah? And you can feel that physics answer all of your questions. Your questions about nature, your questions about something, how it works. Why is it doing like this? Why is it doing like that? And it will satisfying yourself. Physics is going to be satisfying yourself, and you start love it. Then nobody will ask you to learn and study about physics, but you can understand physics. You start to learn physics by yourself. Okay. Another thing which is quite important and interesting about physics is because you will not learn about physics, but you will learn about math. Yeah, because math is just the language how the scientific need to communicate, need to make the short explanations without any losing of the understanding. So everything will be there, and everything will be much easier to share and communicate it. So you are going to learn about physics, but you can also understand math. And for some reason, math for high school students, this is very, very challenging and interesting. Yeah, a lot of students crazy about math. Yeah, and not only that, you can also even learn about English, because in physics, some literature or some media they runs in English, and by doing that, because you love physics, so you will watch couples of videos, couple of materials, you read couples of literature and sources in not your own language. So you are going to learn English by the process because you love physics. So interestingly, your level of English is going to be improving, then you're going to be broader insight, broader linkage, yeah. Your standard is going to be upgraded, yeah. It's quite beneficial for students, and they will be able to level up into the international engagement and standards, because you speak up with English, you're doing calculation with your math, and it's not very easy math. You will start with very complicated math. So that's the benefits and the change paradigm between physics is hard, but no, physics is interesting, it is fun, it's beneficial, and you will be satisfying by yourself because you love physics. Physics will do for that. Just enjoy, taste it, and enjoy it. All right. Okay, and the last questions is very crucial as well. It's about the vacancies, the job vacancies, or the career that physics graduates can apply for their job or career. All right, so I can say because this is very pivotal, this is very, very fundamental, so you can go everywhere. Basically, that's the truth, that's the rules. And also, while you're doing your job after you graduate from um, School of Physics, you can apply for various companies, various institutions, and I can mention some of them, all BUMN, okay, like Pertamina, PTKI, Inka, Telkom, BMK, BMKG, etc. A lot of things, logistics, mining, yeah, you can do. And then most of them are, maybe if I can make the percentage, is more than 30%, 30 to 40%, they are working or doing in the information system, okay. Information system company like Astra Digital Corporates and all of the companies, they are working as the databases experts, cyber security, or networks analysis, system analysis, and so forth. They're working in the informatics systems. Maybe you're questioning why they are not system informatics students, right? But they can do. Why? Because we understand all the principle, and it's much easy, okay. It's easy, just one click you can get the information system, you can develop the system. As you know, the Airlangga University, as the fourth university in Indonesia, we are the best fourth in Indonesia, and the system informatics or the cyber campuses from this university was developed by physicists. We made and we developed it. Okay, it's already 10 years ago, more than 10 years ago, I think, and it's already established. So it's very easy for all of the graduates can apply and get a job in informatics system. So as I mentioned before, it's about 30 to 40%. And some industries, LG, Samsung, and media industries, electronics they can apply for. And also this is quite common because we are in the fundamentals, and most of them are applying for national research bodies. National research bodies belongs to governments. National research bodies belongs NGO, mm, uh, private sectors. Basically, that's in the research and development. Okay, there's abundance about this. Okay, um, hospitals. Wow, this interesting. Hospitals. Usually, you are going to be as a medical physicist, yeah, medical physicist, or you're working with CT scan with some instrumentation in the hospitals, and you know differently compared to some radiographer or some toolsman in the hospital, because you know the basic, you know the interaction between the radioactive materials and human body tissue, or how the dose need to be recalculated to be reassigned, and so forth and so forth. So yes, you are pretty much sure that hospitals is kind of the spectrum that you can apply for, and not everybody in School of Physics has biophysics or medical physics, and we do have that thing. So once you graduate, you are able to apply to hospital. If you can see the government, like the public hospital in Surabaya, the biggest, maybe we are in Surabaya, right? So we do have Dr. Sutomo as the province government sectors. So it belongs to governments in the province level, and we do as well like Dr. Suwandi hospitals as the Kota Surabaya. So this belongs to the city, the government, and one of them employs our graduates. Yeah, the graduates was structured all of the CT scans facilities. They need to take into account the effect of the radiations and the safety for that things. Yeah, they're doing that job very well, and it's already certified, so they're proud about that. Okay, so that's hospital for medical physicists. And of course, because we are in fundamentals, we do understand about the concept, the principle. Then we go for the lectures. Yay, lectures as the universities. This is quite proud, quite prestigious. You can apply for the private universities or public universities. Yeah. And that's not only for physics, not only for mathematics. You can apply for engineering as well, for like the physical engineering, like the electronics. You can do, because we learned about that things, and it's similar. You are learning. You're doing electronics. What is the difference? Electronics is just electronics. Control system is just control system. You just do and implement the differential equations into something related to the electronics, right? No difference. You can do that. Teachers, some of them, they're doing teaching because they love students. Sometimes they do playing with students and teach some subject, little calculation about physics in medium level, like in junior high school or even the early high school. So you are doing the teaching there. So, and for some reason, if you are good in physics, you must be very good in teaching about physics, because you can make it easier for all of the students. Okay, if your students getting confused and crazy, scared and worried not too much about physics, no, you are not a good teacher. So don't go over it. Yeah, do differently you can do for the industries, because you are not too good doing about teaching. Yeah. And also banking. Okay, banking. A lot of graduates worked on the banking, but again, it's not like the frontliner or whatever. This some of them are, like, for some reason the students, the female students are very um, good looking, right? Nice, sweet, yeah, very pretty. They can do as the staff in the frontliner in the bank, but not always. Some of them are doing like databases, uh, 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 like internet security, things like that, or about the system, how to develop the security system in the bank. Okay, so that's pretty much interesting jobs. If we look through all of the alumni, I can't mention one by one, but that's very outstanding. And you are not going to imagine that we are capable to do that. Yeah. Some people do things that it's going to be done and performed by engineering, but to be honest, there's no difference between physicists and engineering, because historically all of the engineering stuff, uh, we, we we do the same. Okay, we do the same. We learn about the same principle. We do the same calculations. So yeah, you can do. If you're crazy about engineering, but you are not accepted on that faculty because it's very competitive, very tough, just go for physics. Just go for physics. It's the same in developing countries, developed countries, wherever you are going, the same. Okay, physics is the basic of engineering, so you can go for it. We bring all of the people, we bring all the students, go to the industries, go for the very good job. Okay, in Malaysia, in Singapore, in Canada, you can do. Yeah, as long as you love physics, you love the basics, and then you will understand all of the concept in engineering. And that's just for one click, so you get it, right? Thank you very much for your attentions, and we're waiting for your admissions. You're turning up to our schools. School of Physics, Faculty of Science and Technology, Airlangga University. Bye for now.